A fascinating construction project in Bezons, France, is showing just how quickly 3D printing technology can transform the way buildings are made. A company called Plurial Novilia recently completed and handed over Vilia Sprint 2, a 3-story social housing development featuring 12 apartments spread across 800 square meters of living space. Every apartment comes with its own timber balcony, giving residents a comfortable outdoor area to enjoy. What makes this project stand out is not just the speed of construction, but also its unique design. The building features a gently curved exterior wall and a rounded floor plan, creating a modern look that would normally add significant costs to a traditional construction project. Thanks to 3D printing, those curves were created without the need for expensive custom molds or complicated building techniques. The structure was built using a large-scale 3D printer, supplied by Cobod, and operated by Perry 3D Construction. The machine sits on a movable platform, allowing it to be repositioned around the site when needed. Using a specially developed concrete mixture from Holcomb, the printer deposits material layer by layer through a nozzle, creating walls and partitions with impressive precision. Whether the design called for straight lines or complex curves, the machine handled both with ease. One of the most impressive aspects of the project was the speed. The actual printing process took only 34 days, significantly beating the original goal of 50 days. Even after completing the remaining construction work, the entire building was finished in about 3 months. For comparison, a nearly identical building constructed using conventional methods on the same site required around 6 months just to complete its framework and needed roughly twice as many workers. In the end, the 3D printed project reached completion about 3 months faster than traditional construction. The environmental benefits are equally impressive. The concrete arrives at the site already mixed, reducing transportation needs and cutting down emissions associated with extra deliveries. Since the printer follows highly efficient paths and eliminates the need for temporary molds, the building used about 10% less material than a conventional box-shaped structure. The concrete mix also contains synthetic fibers for added strength, while its formulation reduces carbon emissions by roughly 30% compared to standard concrete mixtures. After the printing phase, workers added additional perlite insulation and completed the interior finishing. The building also incorporates around 500 square meters of rooftop solar panels. Combined with a hybrid gas and heat pump system, these features help the development achieve approximately 60% energy self-sufficiency, while meeting France's modern emission standards for residential buildings. Today, people are already living in these apartments and benefiting from a construction process that delivers housing faster without sacrificing quality. And this is only the beginning. Encouraged by the success of Vilia Sprint 2, Plurial Novilia is already preparing an even larger project featuring 40 apartments. This next development will use 2 3D printers working simultaneously, which could reduce construction times even further and showcase how rapidly this technology is evolving. Projects like this offer a glimpse into the future of construction, where buildings can be completed faster, use fewer resources, and provide sustainable housing solutions on a larger scale than ever before.